Okay. Hi, my name is Brandon, and I'm going to be explaining a wave. So, this is what a wave looks like. This is the median point on which a wave travels through. The reason a wave happens is because there's a particle at one point at a medium, and when that particle moves, it vibrates. And when there's a constant vibration, it's called a pulse. And then a repeating pulse is called a wave. The point from the medium to the top of the wave or the bottom of the wave is called the amplitude. The tops of the waves are called crests, and the bottoms are called troughs. The reason this is the amplitude is because it's the distance from the maximum displacement or the minimum displacement from the median point. Okay, so the points from the two crests or the two troughs are called the wavelength. Because a wave is in the shape of a sine curve, any point that is on the corresponding sides of the wave are considered wavelength. So a point over here and a point over here would be also considered a wavelength.
The different components of a wave can be plugged into equations. For example, the frequency of a wave, which is represented by lowercase f, is equal to 1 over the period, or t, of a wave. Because frequency is equal to 1 over the period, that means the period is equal to 1 over the frequency. The period is the amount of time in seconds that it takes for one cycle or one oscillation of the wave to complete. Therefore, the frequency is measured in cycles per second, or hertz. And the period is, of course, measured in seconds. Now, the wavelength, which is represented by Greek symbol lambda, is in an inverse proportion to the frequency. When multiplied together, they equal the velocity of a wave. So, because they're in inverse proportion, the higher the frequency of a wave, the lower the wavelength will be. A lower frequency wave will have a longer wavelength.
So in this problem, we're going to demonstrate how the wave formula works. The wave formula goes like this. The speed of the wave is equal to the frequency times the wavelength, which is represented by lambda. As we have here, the speed of the wave equals 100 meters per second, so I'll plug that in for the V. And the wavelength is 15 meters per second, so that will be for the lambda. So we are looking for the frequency. So we divide both sides by the lambda, which is 15. And our frequency turns out to be 6.67
Hertz.
hertz. Now that we have the frequency, which we got from the last problem, we're going to use this frequency to find the period. The period is the amount of time that it takes to complete one cycle. So the formula for the period, which is represented by t, equals 1 over f. We plug in the frequency, which equals 1 over 6.67. And we get t equals 0.149, or 0.15 seconds. And that's how long it takes for the wave in the previous problem to complete one cycle.